going to start chapter 2. And in physical science, remember we're breaking physical science down into two different lessons, physics and chemistry. And we are going to start learning about the chemistry. So where do we start learning about chemistry? What are we going to start with? Well, think of chemistry as cooking. So think of chemistry as cooking. The lab, we have our equipment. And the directions is our cookbook, our recipe, but what are our ingredients? Our ingredients are elements. And what is an element? It's a substance that cannot be broken down into anything more. So it cannot be broken down into anything more simpler. There are 115 elements on the periodic table. Everything in the universe is made from those 115 elements. So for example, a couple of those elements, carbon, oxygen, hydrogen. Those are pretty common ones. You might know iron or silver or gold. Those are also all common elements. If we take an element and look at what composes an element, what makes up an element? An atom. And an atom is the smallest building block of matter. And it's how small is it, you ask? If you have a 20-ounce bottle of water, and you guys can all kind of visualize what a 20-ounce bottle of water looks like, you're going to have about 10 to the 25th atoms of oxygen in that water. That's not including the hydrogen. That's just the oxygen. You're going to have 10 to the 25th atoms of oxygen in that bottle of water. So atoms are incredibly small. They're the smallest building blocks of matter. No two elements have the same atom. So if I have a room full of oxygen atoms, they're all going to look the same because they're all oxygen atoms. But if I have oxygen and iron atoms, they're going to look different. And we're going to talk about why they look different. Most elements are solid at room temperature. And tomorrow I'll pinpoint on the periodic table exactly which ones are solids, which ones are liquids, and which ones are gases at room temperature. They can change states, though, under heat or pressure. For example, carbon can exist as charcoal. It can exist as graphite. And if it's under the ground and exerted under lots of heat and pressure, it turns into diamond. So elemental carbon can form in a couple of states. And that's just one of the examples. All the elements come in have varying types. All right, and can come in different forms. Some of them are just one form. For example, oxygen. Oxygen at room temperature is a gas. It's always going to be a gas at room temperature. So we are going to talk about these elements. Why? Because in chemistry, you can't cook without understanding your ingredients. And our ingredients are the elements. Now, what happens if we take some elements? We start to do a recipe, and we have to mix two elements together. What's going to happen? We're going to form a compound. So what is a compound? A substance made from two or more simple substances. Really, a compound is two or more elements combined together. Two or more elements combined together. Now, what is an example of a compound? You'll see here, we have NaCl, that's table salt, or sodium chloride, H2O, water. You may know a couple other elements. CO2, carbon dioxide, and this one might be one of your favorites. This is a good old-fashioned blood sugar. C6H12O6. And I've listed a couple, there's a couple others here that you want to look at, but those are all compounds. Two or more elements broken together form a compound. So to review, we have atoms. They're the smallest building block of matter. A bunch of atoms of the same are called elements. You take two or more elements together, you get a compound. What happens if we mix two compounds together or two different things together? Well, there are two choices. First one is a heterogeneous mixture. All the parts are going to be different. It's going to look different. It's not going to look like the same solution. And in fact, if it's homogeneous, it's going to, everything's distributed evenly. What's a great example of homogeneous solution? Kool-Aid. Is Kool-Aid mixed evenly throughout? Absolutely. So everything is evenly distributed. It's a great example of a homogeneous mixture, Kool-Aid. Now, what's an example? What is an example of a heterogeneous mixture? Parts are different from one another. Anyone like drinking orange juice in the morning? Anyone like drinking it with pulp? Where does the pulp settle out? The pulp settles out to the bottom. Therefore, the top of the orange juice is very different than the bottom. So a heterogeneous mixture is not mixed evenly. A homogeneous mixture is. And if we break it down, we can look at 3 categories of mixtures. We have solutions, suspensions, and colloids. Let's look at the first. What is a solution? A solution is anything that dissolves and forms a homogeneous mixture. So right now, what are 3 beverages that are dissolved that you drink, all right, that are homogeneous, the same throughout? Well, I could come up with a couple here. How about Gatorade? Already came up with one. Well, we already came up with Kool-Aid. We have Gatorade. We have lemonade. I know some of you like flavored water using that new Mio stuff. Those are all examples of solutions. All right, that substance dissolves and it looks the same throughout. So that is a solution. Solutions are homogeneous, the same throughout. Next up, we have suspensions. Suspensions is a heterogeneous mixture that separates into layers over time. What is something that would separate over time if you let it sit? I'm thinking something you pour on your cereal. That would be really disgusting if you left it out. All right? Milk is a suspension. Milk will separate over time. What else? What is something else that will separate over time? Guys ever like get your ketchup? Ever get your ketchup and you go into the fridge and there's like an inch of water on top of your ketchup and you have to shake it all up again? That's a suspension. What else? Here's a great one. Salad dressing. Any of you like Italian salad dressing? You go into the grocery store, you look at the salad dressing, and the salad bottle looks like this, right? What happens? It separates into layers, right? You have oil, you have the water, you have vinegar, then you have like those red pepper spices on the top, right? And what do you have to do before you use vinaigrette? You have to shake it up. So a salad dressing is a great example of a suspension. A suspension, something that will separate over time. So just something to think about. Then lastly, there is one other type of kind of mixture that we can talk about, and this is called a colloid. And a colloid's kind of difficult to understand. A colloid contains particles that are intermediate in size and they're stuck between smaller particles. Light can't go through a colloid. And you're thinking, man, I knew what a solution was, I knew what a suspension was, but I can't give an example of a colloid. And colloids are tough because you don't really know too much of them. But light can't travel through. An example of a colloid would be ice cream. You have frozen particles of ice mixed in with frozen particles of cream. All right, you have fat and water and milk all combined together, and it's frozen. Colloid's a great example of ice cream. Also, all right, if I stir like a mud puddle, that mud puddle is going to stay stirred up for a long time. It's not really going to, all right, it's not much of a suspension, but it's going to stay muddy. That could be a colloid. You can kind of consider that a colloid. So ice cream and mud puddles. So 2 things to consider there when we are talking about the solutions or mixtures. So we have solutions, suspensions, and colloids, and we will work with that when we move on in the chapter.